Hey guys, I hope you are fine. So today we are gonna solve the problem of the day for 17th January. Uh, let's begin with the problem. So this is the question is neighboring bitwise XOR. Okay, this is also a problem of XOR. This is a medium type of problem, and topics are of course bit manipulation and array. Okay, the question is a zero indexed array derived with length n is derived by computing the bitwise XOR, okay, of adjacent value in a binary array original of length n. Okay, specifically for each index I in range 0 to n minus 1, if I is equals to n minus 1, the derived I is equals to uh, okay, and otherwise derived I is equals to, so these operations we have to do whether. So okay, I understood. So the question is, okay, so the question is, uh, let's suppose an array original, right, having a length n, and we have to apply these much, uh, we have to apply all these operations, that is derived I. So derived I is equals to original I XOR original I plus 1, right? And if n is equals to, if I is equals to n minus 1, so the derived I is original I XOR original 0, right? We are given derived, and we have to check that if they present a original from which doing those operations can we make a derived array. Okay, so for this particular case this is true. The example is, so the explanation is original, so the output will be 0 1 0, which is so let's check. Zeros or 1 will give 1, ones or 0 will give 1, and zeros or 0 will give 0. So yeah, this is mm, so let's think about it. How can we solve? I suggest you to pause this video. I suggest you to pause this video and try this solution by your own. Try this question by your own. If you find the answer, please share it in the comment section. So let's. I hope you are done with this. Let's. So uh, I will also try this by my own. So let's think. What can we do? What can we do? Uh, Let me think. Give me a minute. Mm. Mm. क्या कर सकते हैं भाई? Okay, so guys, what I'm thinking is, so let's write this example here. So the derived array is, so okay, so the derived array is this. What I'm thinking is, let's suppose a original array, right, which always starts with a 0. Let's suppose this. So can we make it 1? So yes, this is a original array right now. We don't know what came in this and this. So can we make it 1? So of course we can make it. So how can we make it? We will just make it 1, because 0 and 1 will become 1. Okay, now we are at 1. Can we make it 1? So yes, of course we can make it. Just put 0 here. 1 and 0 will become 1. Okay, that's satisfied. Now can we make it a 0? So we have to check that 0 and 0 become 0. So yeah, so it's a true. Let's take a second example. Equals to so first element will be always 0. So can we make it 1? So yes, we can make it 1 by using 1. So does it it will be 1. So 1 and 0 will be 1. So that is a true. Let's take third example. Original is equals to 0 comma this. So can we make it 1? Yeah, this one will make it 1. Can we make it a 0? So no guys, we cannot make this 0, because this is the only possible case. If we take it 1, so we have to take 0 here. This will also not possible to make this derived, right? So as you can see the the time complexity here is O of n, and space complexity we can do it O of 1. Let me write the code, and let's check if it is the best possible solution or not. While writing this code, I will also think about a better approach, but currently I am able to think for this approach only. And looking at the time complexity, it's well, I mean, we can solve this in this time complexity, right? Because the n is the range of the n is 10 to the power 5 only, right? So now make a I think current element, which is a 0 right now, because we are at because 0 so the current element is 0. Current element is the element which is at present I is equals to 0 right now. So while I less than so n, what is n is equals to length of derived, right? So while I is equals to I is smaller than n, we are at 0th element, right? So I is no, so I is 0. We are at 0th element. If so it is n minus 1, because we will do it till here, and for this we have to do a different thing. For I smaller than n minus 1, if derived I plus 1 is not equals to derived I, right? So the current, if not equals to this, then current will become opposite of this. Current equals to not else current will remain same, right? derived I plus 1 is not equals to derived. Okay, let's make it like this one. Okay, now if okay n is 1, so if okay, let's also think if let's write here if n equals to 1, so return derived 0 equals to 0, right? So what I mean this, if n equals to 1, right? So whatever we take here, it will get stored here, right? So if original original is either 1 or 0, so 1s or 1 will be 0 and 0s or 0 will be 0. So the derived 0 will always be a 0, right? If it is a 1, then it is not possible. Okay, now okay, if so if now if derived n minus 1 is n minus 1 equals to derived 0. So if derived n minus 1 is equals to derived 0, that means the current element should have 1, because so the first element is 0, right? So current element should have 1. Sorry, I have written a wrong code, guys. So let's write the rules, guys. Okay, for so rules are so first take original 0 equals to 0. Always take original 0 equals to 0. If derived 0 equals to 1, original 0 or current element. So we are not okay, so let's leave this. Original 1 will also be 0, else original 1 will be 1, right? So that means if derived I equals to 1, original I equals to original I minus 1, 1 else original I equals to opposite of original I minus 1. Okay, so that is the rule, guys. Now I will make a current element. So okay, so let's make original array, which is 0 into length of derived. Also another rule, guys, if length of derived equals to 1, right? So let's see if derived length of derived is 1, so that means the original array will also be a 1, should also be a length of 1. So that means original is either this or this. If we take XOR of 1 comma 1, it will be always 0, and if we take XOR of 0 comma 0, so it will be 0. So that means derived 0 should always be 0, right? So let's make n equals to length of derived, right? If n equals to 1, you are written derived 0 equals to 0. If this is true, that means we can make, so this is a possible case. Either this is not a possible case. So original is equals to length of derived, original equals to O of n, right? It means okay. Now for I equals to 1, I in, so while I less than n, if derived I minus 1 if derived I minus 1 equals to 1, org I equals to org I minus 1, else org I equals to absolute of org I minus 1. So what is mean by absolute? So if org I is equals to org I minus 1 is equals to 0, so that will make it minus 1. So absolute of minus 1 will become 1, and if org I is equals to 1, that will make it 0. Okay, now org I is equals to org I minus 1, absolute of org I minus 1 minus 1. Okay, or I can say org I minus 1 plus 1 and 2. So that means if org I minus 1 equals to 0, plus 1 will become 1, and 1 percentile 2 is equals to 1 mod 2 is equals to 1, and if it is a 1, so that will become 2 mod 2 is equals to 0, and if you want to mod 2, we can make and 1, right? Okay, now we have org n minus 1. So if derived n minus 1, which is last element, equals to 1, if derived n minus 1 if derived n minus 1 equals to 1, that means return org 0 not equals to org n minus 1, else return org 0 org n minus 1. If derived n minus 1 equals to 1, right? So if this is a 1, that means these two should not be equal. So that is the case. And if it is a 0, that means these two should be equal. So there is the case. So guys, as we can see, instead of using this org, right, org array, what you can do is we can make a current array which is 0. So if derived, so and we will make it like, okay, not here, so it is like current equals to current, and current equals to current, and this is a current, and org0 is always a 0. So we can prevent we can prevent making a array of length this, so our time complexity will become, so our space complexity will become O1. So that's what I'm telling. Now we can also remove this case. So we can just do this and this here. So I think this should get passed. Let's try. Okay guys, sorry. I plus equals to 1. I think this should get, okay, this is a wrong case. I should be a 0, sorry. Sorry, I should be a 1, my bad guys. If derived 0 is a 0, sorry, if derived 0 is a 1, so current will be current. Let's try this. I think this should work. Yeah, so guys, this is working fine. Let's submit this code. So guys, this is a valid code which is giving us good time complexity. Let's think of a different solution. Total XOR. Okay, what is this? This is a valid, so nice thinking. This is a very valid point. So as you guys can see, this is num0 XOR num1, this is num1 XOR num2, this is num2 XOR num0, right? So this contains every element 2 times, right? So num0 will be there and there, num1 is there and there. So okay, so let me explain this. So okay, so this is my solution. Now let's try for the best solution. Okay guys, so let's derived is this, right? So let's say derived is x, so that is y, that is y1, that is y1, y2, y3, and so on, right? So original is, let's say, x1, x2, x3, so on, yn, this is xn, right? So what we can say, y1 is equals to x1 XOR x2, y2 equals to x2 XOR x3, and so on, yn equals to x0 XOR xn, right? So x1 XOR xn. So what we can say, y1 XOR y2 XOR y3, and so on, yn equals to what, x1 XOR x2 XOR x2 XOR x3, and so on, xn XOR x1. So as we can see, all the numbers x1, x2, x2, x3, x3, x4, x4, x1, x5, xn, 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 right? It's like, so all the numbers are present 2 times, so this should be a 0. Okay, if this is a 0, that means this is a valid case. Okay, so this is the most optimized things we can do. So in this thing, we don't have to do if else. So if else, so this will also prevent our too much time. वैसे तो the time complexity is on only, time complexity is on, but it will prevent so much if else, right? So XOR equals to 0 for I in drive, XOR equals to XOR I return XOR so guys, this solution is accepting, yeah, 80% with the best time complexity. So this is the best solution. We have done this in O1 time complexity and O1 space complexity, but still this is something which we need to think. This is something which we need to think in terms of solving this problem in the best possible case, right? So I hope I will share this solution in the comment section. I hope you understand the solution from the most native approach till the best approach. I'm trying my best to give you all my knowledge. Also, I will try to I'm trying to improve my communication skills so that I can provide you the best knowledge. Thank you guys. Thank you for your patience and your time. Thank you for watching this video. Thank you.